Y'all okay? All right. Let's talk about everybody's favorite. I know you just can't wait. This is the last little bit of review stuff, and then we'll start with the Monday. We'll start with calculus. Tell me, how can I write that another way? Oh, frick. That's right. B to the x equals a. This is exponential form. The other's logarithmic form. What happens if there is no base? Yeah, that's right. It's an implied 10. Good job. What other special log do we have? Natural log. And what does that mean? That's the log base. That's exactly right. Y'all remember this really well. Let's see if you remember the properties. We did. Yep. Tell me when you got it. Good. How could I solve that for x? We kind of just did that. But what would you do? That's exactly right. I would put e to the 3t plus 5 equals x, especially now we have to get out of the mindset of thinking there won't be variables in our answers, because that can surely happen. Now you won't just get one numeric answer for sure for everything that you do. What if I had, I don't want to move to, how would you solve that for x? You got to condense that, combine them first. So how do I, because I can't just add logs, right? Can't just all willy-nilly add logs, but you can condense them using those log properties, which says what? That's exactly right. So log base 2 of 7x equals 4. And now it's a problem just like before. Do y'all need me to list out those properties for you? Yes, okay. There are 3 log properties. I'll just do this first one that we just did. And you can go backwards or forwards on this. Let's say log base b of x plus log base b of y equals log base b of xy. As I move from left to right, I'm condensing, and if I move from right to left, it's expanding. I also have one that allows me to subtract. What do you do then? How do you condense that? You divide them. That's right. Log base b, x divided by y. There's one more. If it has an exponent here, what happens? That, you're exactly right. You move it around to the front and multiply. And then there are a couple of properties that follow these or stand to just from basic definition of logs. Things like if you raise some value to a log and the base of the log is the same as the base here, what does that simplify to? Y'all remember? X. These just cancel. Y'all remember that one? No, clearly not. So if this was e to the natural log, we'll use this one a lot. E to the natural log of whatever, 5, this would just equal 5 because natural log is, of course, log based. What if you didn't have a calculator and you needed to, or what if you had a calculator that only did log base 10 and natural log and you need to evaluate a different base? So in other words, let's say I needed to know what is log base 2 of 7 and my calculator won't let me change the base. What do you do? Anybody remember that one? Close. You do log 7 divided by log 2. You can divide any log this way. This is called change of base. It works for any log. And I know this is fast, so if y'all need me to slow down, tell me. This is just a little recap here. This is not something you're going to use with everything, but as it pops up in problems, I want to make sure you remember. You can change this to anything. So this is a base of 10. I did that because your calculators are base 10, right? Do I? Is there? Okay. The nicer ones, the newer ones, will actually let you type the base in. There could be some problems that you encounter, though, that there are variables in here, so you're not actually evaluating. You're trying to get stuff to cancel out. You see what I'm saying? So just to know that change of base formula is also helpful, too. But, yeah. All right. Everybody good? Well, for logs, I think. Compound interest, remember that? Specifically, really the one that we will focus on is, I'm sorry. You don't remember that where we did, I said, do you have $500 and walk down the road to safe, and then somebody else has $200 and goes to First Palmetto, and they got this interest rate here and this interest rate there. Yes, I think, yeah. Did y'all do the Future Life projects? Yeah. Oh, that was algebra. No, that wasn't for y'all. I'm telling you, you will use more stuff you learned in algebra 2 than anything else in here. This is when you have compounded interest that's compounded continuously. That's when you use PERT. It's just an equation, so it's P times E to the RT. Remember, we had those growth in decay, so we had A times 1 plus, this was whenever it was compounded quarterly or monthly or daily or anything like that, but if it was compounded continuously. And compounded just means interest on interest. You make money on the money that you've already made. Most of the time, this is the most applicable one. Yeah. Yeah, but you don't have to worry about that one. No. Your P is your initial amount or the amount you take to the bank and you deposit. R is your interest rate as a decimal. And T is, of course, what? Time. That's the E, yeah, that goes. All right, I'm going to start asking you a few questions. You tell me if you remember, and if you do, tell me the answer, and if you don't, then I'll go over it. So make sure you let me know. What does it mean to be a function? There you go. Graphically, what does it look like? How do I test for a function graphically? There you go, vertical line test. What does it mean to be one-to-one? Look at you. I'm telling you. Okay, what does it mean to be one-to-one? And that's a big, that'll be big, one-to-one. You want to write that down. You don't have to. Yes. As long as it doesn't start doing that, because then it wouldn't. I think they're talking about like that line. Oh no, that would not. Speaking of inverses, what's an inverse? What happens? Good job. You switch x and y. So inverse means switching x and y. So if I have f of x, I would indicate its inverse as being the -1 exponent there. This means inverses. Y'all, please tell me if you don't remember some of this stuff and need me to change of base. We talked about logs. If I told you that these two are inverses, do you remember doing composition like this where we plug one function into the other? What happens if you plug an inverse into another inverse or into its inverse? Remember, do you remember whenever we had to verify inverses by doing this both ways? X, you get X, good job. It should reduce down to X both ways, forwards and backwards. That's how we kind of prove the inverses there. Nice. Again, I'm not trying to throw a whole bunch of stuff on you. You're in a right triangle. Oh, sorry. Tell me when you're done. Any of this stuff that you need practice or extra help on, let me know. The actual X. Like this is where we'd put a bunch of stuff in and we'd end up getting something like 2x minus 5 plus 5 over 2. And we'd say, okay, well, that cancels. And then that cancels and it simplifies down to just x. Well, yeah, so you'd end up with this, which would then cancel. What does that symbol mean? Theta. That's theta. That's exactly right. We'll use that a lot too. Let's say this is x, y, and z. What is the sine of theta here? What is the sine? Somebody said it just now. Y over z. If I'm talking, remember, in terms of a triangle, and essentially that's what I'm doing on my unit circle too. The only difference is that hypotenuse is always 1. That's why it just takes that one side length. Do y'all remember this? What is the cosine of theta? X over z. How about the tangent? What about the cosecant of theta? There you go. Secant and cotangent's easy. What if I needed to know, what if I knew that the sine of theta is 1/5? How could I find theta? Mm-hmm. Inverse sine of 1/5. You're exactly right. Inverses cancel out, right? So theta, y'all are making me look bad now. Preston's getting all the answers from his other pre-cal teacher. The inverse there allows that, it kind of cancels it out, essentially, is what you can think. Like if I inverse both sides, right, that would cancel it out and leave me theta. So anytime you have a trig function and you need the theta value, you can just do the inverse trig function to get rid of it. Y'all okay? I know trig's going to be what kills you, what throws you. Yeah. Cosecant is the reciprocal of sine, yes. Are you talking about in the red or in the green? That's the inverse sine. So inverse and cofunctions are different. So cofunctions are reciprocal functions. Inverses, that's where we switch that x and y and we change things up, so they're a little different. Yes, if I told you sine theta of 1/5, right. So we have inverses, which are and so on, and then we have the cofunctions, which are reciprocal functions. And I'm glad you say that because they're very different, and they do you start to get them confused for sure. Ooh. What is the period of a sine or cosine graph? The parent. The parent. What does it mean to be what's the period mean? Oh, it's like how long does it take before it repeats the pattern? Oh, it's like 5 or pi. It's 2 pi. 2 pi. It takes 2 pi to make a complete. Think about going around that whole unit circle, right? It takes 2 pi before everything starts repeating again, and then it keeps looping and keeps looping. So the period is 2 pi. I'm going to stop there because I'm going to give you some trig functions. I've already given you the parent graphs. Make sure you have